tree is always free from cycle. We need to recognize minimum spanning tree from the connected graph. Then for that purpose, for that scenario, you are supposed to give me a call. Spanning tree. Minimum spanning tree, is it? Yes. Yeah, using that particular logic, and that logic is known as a Kruskal algorithm, is it? Okay, now we are online, it's recording is there. So let's move for the next unit, that is unit number 5. Now what is unit 5? Unit 5 is all about matrices. Now we guys are going to learn how we can represent a graph using matrices, using matrix, is it? अगर ग्राफ को पूरे मैट्रिक्स में कन्वर्ट कर देना, so we are having lots of operations with the matrices. We are good how to add two matrices. We are good how we can multiply two matrices. We are good how we can identify eigenvalue of a matrix, eigenvector of a matrix, how we can go for the inverse of a matrix. We are good with so many operations related to matrices. And once we are able to connect graph with matrix, then the entire world is there for us. We can move in any of the field using that. क्योंकि matrix हर एक field में हम present कर सकते हैं. If we wish to represent vector space with the use of matrix, yes, we can. All the students who are from the AI, you guys are learning a vector space with the Chetan sir. Is it? Is it yes or no? No. During this particular semester, you are having a kind of special lectures of Chetan sir Vgl.
Yes sir.
But सारे बच्चे वो नहीं अटेंड करे होंगे. All those who are in the AI only. जिसको MLE जिसने ऑप्ट किया है, जिसको आ रहा है, उसी के लिए वो सेशंस रहेंगे. बाकी के बच्चे जो बिग डेटा वाले वो नहीं पढ़ रहे, पर ऑल दोज वो सारे AI वाले बच्चों को पता है कि हाउ वी कैन वो मैट्रिक्स को वेक्टर स्पेस में कैसे गुजार सकते हैं. Is it? If we are good with the system of linear equation, then पूरा मैट्रिक्स है वो. You can represent any of the system of linear equation with the use of matrices, और उसका solution, उसकी consistency जो भी find करनी है वो matrices से हो सकता है. Eigenvalue, eigenvector, if you are good with that, बहुत ज़्यादा information collect कर सकता है आप matrices की मदद से. So now this is our task once again. What we are doing, we are going to connect both these concepts, graphs and matrices. Is it? Graphs and matrices. So we will be having 2-3 different ways how we can represent कभी हम वर्टेक्स के ऊपर से कर रहे हैं, कभी हम एजेस के ऊपर से कर रहे हैं, कभी एज वर्टेक्स दोनों को मिला के कर रहे हैं. क्या है ये अभी देखते हैं आगे इस पूरे यूनिट में. Introduction, I had already explained this, forget about that. I will share this PPT one. Let's have a small revision of adjacency of vertices and edges. When we can say that two vertices are adjacent, when we can say that vertex and edge is adjacent. Is it? In a graph, two non-parallel edges are said to be adjacent. In a graph, two non-parallel edges are said to be adjacent if there is a common vertex between two edges. क्या बोलना चाह रहा हूँ, क्या बात कर रहा हूँ? It is quite simple. Suppose I'm having this 3 vertices A, B, and C in front of me, and two non-parallel edges. Observe both these edges. Let me label that edges as E1 and E2. Now, I want to say that E1 and E2 are adjacent edges. Why? Because edge E1 as well as edge E2 both are having one of the endpoint which is common in both of them. Is it? A is the endpoint of E1, one of the terminal vertices of edge E1, as well as vertex A is also one of the terminal vertices, one of the terminal vertex of edge E2. Is it? So by that way we can say that two non-parallel edges. Observe that E1 and E2 both are non-parallel edges. Is it? Two non-parallel edges are said to be adjacent. ये दोनों edges है वो adjacent है क्योंकि कोई एक vertex है जो दोनों में common है. Is it? So that is what I had mentioned over there when we can say that two non-parallel edges are adjacent. Let me move ahead. Let me erase this ink. Here A and B are adjacent vertices. A and B are adjacent vertices. When I can say that two vertices are adjacent, if we're having a connection, if we're having an edge between two vertices, then surely both that vertex is known as both that vertex will be labeled as adjacent vertices. Is it? देखिए A और B adjacent vertex है क्योंकि हमारे पास उन दोनों को कनेक्ट कर रही है एक एज है. Here A and D is also adjacent, A and C is also adjacent. Is it? Even B and C is adjacent. Is it? So adjacency of vertex, adjacency of edges क्या है हमको पता है? But B and D are not adjacent. देखिए B और D के बीच में कोई edge नहीं है, तो I cannot say vertex B and vertex B is adjacent. Is it? ये सारी बातें हमको पता है, इसलिए मैंने लिखा हुआ है देखिए ऊपर revision. Is it? All this stuff we had discussed in the previous unit, that means unit number 4. Now let me move ahead here. We are good with this. We are good with this. Edges even and E2 adjacent, ये बात हो चुकी है अभी कर लिया. Now adjacency matrix. Let's go for the adjacency matrix. Now how we will prepare our adjacency matrix? The adjacency matrix of, पहले तो यहाँ पे लिखने में गलती है, there's a kind of typo, it should be matrix. Matrix of graph G with n vertices and no parallel edges is an n by n symmetric matrix. Observe that adjacency matrix of graph G was having n number of vertices and no parallel edges. That matrix will be actually n cross n symmetric matrix. N cross n symmetric matrix. That particular matrix will have only two types of entries. Either that entry will be 1 or that entry will be 0. When I can say, when we will allow entry 1, if there is an edge between ith and jth vertex. If we are having one of the edge which connects ith vertex to jth vertex, then at the place aij, we will allot 1. And if we are not having any connection between both that vertices, then respective place will have the entry 0 over there. 0 if there is no edge between ith and jth vertices. थोड़ा कंफ्यूजन लग रहा है, थोड़ा कंफ्यूजन है आपके दिमाग में, सर ये क्या 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 लिख के क्या रखा है, ith, jth and aij, इसका मतलब क्या है? So first of all, let me make you guys clear about the some of the tactics related to matrix. सभी ज्यादातर तो सभी को पता ही होगा, पर फिर भी जो बच्चे शायद let me pick my pen. Yes, matrix. Usually we guys denote matrix with the capital letter. Okay. ये इसको बंद करेंगे ना, तो रुक जाओ. Let me pick a white. This color is not convenient for the students. Those are attending online. Yes, this will be okay. Is it? अब दिख रहा है, देखो तो दिख रहा है ना, visible. Good. Usually we guys denote matrix with capital letters. What is matrix? Matrix is actually a rectangular array. Is it? A rectangular array. Notation हम ये use करते हैं aij usually. And if I'm mentioning m cross n, then that m. If I'm mentioning m cross n, that m means number of rows we are going to include in the matrix, number of rows, and this m means number of columns. Is it? Columns. When I can say that a matrix A is symmetric, कब बोल सकते हैं matrix A is symmetric? Bhavdeep? When we can say that any of the matrix is symmetric matrix? Bhavdeep, am I audible to you?
So when m equals to n.
When m equals to n, then if m is equals to n, then that matrix is known as a square matrix, dear.
Sir, when A
I'm
inverse
asking
is
about
equal to A.
symmetric. Yes, when matrix and its transpose both are same.
The A equals to A transpose.
Oh, yes, sorry,
If matrix
transpose.
and its transpose both are same, then that matrix is known as a symmetric matrix. And take care, when we are looking to construct adjacency matrix of a graph, then surely that matrix will be always symmetric. वो matrix always symmetric matrix ही रहेगा. Now, if we talk about symmetric matrix, अब इसकी ज्यादा अगर बात करें, आप बोल सकते कोई ऐसा मैट्रिक्स है, if I'm dealing with a matrix of the order 2 cross 3, क्या ये symmetric हो सकता है?
No,
Is
sir.
it possible that a matrix of the order 2 cross 3 will act as a symmetric matrix? नहीं हो सकता, क्योंकि इस मैट्रिक्स का अगर आप ट्रांसपोज निकालेंगे, then A transpose will have the order 3 cross 2. तो 2 cross 3 to 3 cross 2 दोनों मैट्रिक्स कभी सेम हो ही नहीं सकते. When we can say that two matrices are equal if each and every respective entries are same, then and then we can say that two matrices are symmetric. बाकी बोल ही नहीं सकते, is it ना? तो when we are talking about symmetric matrix, then each and every case we are always dealing with स्क्वायर मैट्रिक्स, हर बार वो स्क्वायर मैट्रिक्स में ही सिमेट्रिसिटी चेक हो सकती है, बाकी सिमेट्रिसिटी की बात ही नहीं हो सकती, इज इट ना? इट्स वेरी वेरी क्लियर टू यू। अब कोई एक ग्राफ, चलिए कोई एक ग्राफ उठाते हैं, लेट मी टेक यू टुवर्ड्स द प्रीवियस स्क्रीन वंस अगेन, जस्ट टेक केयर अबाउट दिस, एक बार देख लीजिए। I'm going to deal with graph G with n vertices, and it should not have any parallel edges right now, and n cross n symmetric matrix हमको बनाना है, ठीक है? So let me have one of the matrix, one of the graph. Let me have a kind of simple graph. This is a kind of simple graph. That is a simple graph, is it? Let me label my vertices as A, B, and C. Now, if I'm looking to find its adjacency matrix. इसका adjacency matrix बनाना है, क्या बनाना है भाई? Adjacency matrix बना रहे, चल. Now, the adjacency matrix of this graph G. First of all, before going for adjacency matrix, you must be clear कि आपके matrix का order क्या होगा. चलिए, for that we must be good with the cardinality of vertex set of this graph. अब इस ग्राफ में कितनी vertex है? 3 है. Then my matrix will be of 3 cross 3. My matrix will have the order 3 cross 3. Is it? अब यहां पे मैं मेंशन कर रहा हूं just my 3 vertices ABC. Or the row, let me label the vertices ABC. I'm having these 3 vertices over the graph ABC, ABC. Is it? Now, when I'm supposed to allot 1, as per the previous slide, I had mentioned like that adjacency matrix is nothing but a kind of matrix whose entries are Aij, and I'm supposed to give Aij as 0 or 1. कब 0 देंगे अब? If ith and jth row, ith and jth vertex are connected. अगर वो connected है, ith and jth vertex, if both that are connected, then it will be having entry, then it will have entry 1. And if they are not connected, then the entry will be 0. If they are not connected, then the entry will be 0. Is it? तो बताइए, क्या A vertex A के साथ A का कोई connection है? A is having connection with A? No. They are not having any connection of vertex A with A. वो कब हो सकता है? If you are having a self loop. If you are having a self loop over A, अगर यहाँ पे self loop एक है, then I can say that A is having connection with A. Yes, please. Yes. Self loop? What is self loop? Suppose this is if I'm having one of the edge over there, which both the terminal vertices are same. Observe this particular edge. If I'm going to label this edge as E1, then identify both the terminal vertices of E1. दोनों vertex B है, B से चालू हो रही है, B से खत्म हो रही है. So this is self loop, is it? And we are not having any self loop over there. So this particular entry will be 0 surely. Now check whether for this entry A to B, do we have any connection do we have any edge which joins A to B? Yes, we have one of the edge, is it? So I need to give 1 over there. Do we have any edge which connects A with C? Yes, we have. Do we have any edge which connects B to A? Yes, the similar edge. So this entry will be 1. B के पास B वाला कोई connection नहीं है, then it will be 0. B to C as well as A to C भी है. B to C is there, and this is 0. Is it? Is it? This is not unit matrix here. This is, we cannot even say this is triangular matrix. But observe, this is symmetric matrix. Now try to identify the transpose of this particular matrix, then surely you will have the similar kind of matrix. The similar matrix will be there. If I'm going to label this matrix as matrix A, then the transpose of this matrix will be once again same as matrix A. So what is this? This is adjacency matrix of this particular graph. So this is the way we can construct adjacency matrix from the graph. It is very, very easy, is it now? Are we good? Are we good? All those who are attending this meeting online, please drop a message on the chat box right now. Are we good with this? Are we good with this? All those who are attending, I'm just getting reply from 4-5 yet. बहुत ही आसान है भाई. पिछले वाले 3 यूनिट बहुत ही आसान है. Unit 4, 5, 6 is very, very easy. So सिर्फ आपको मेरे साथ रहना है, that's all. कोई बड़ी बात नहीं है, कोई बड़ा लॉजिक नहीं है. Is it good? Good. Let me move further with this presentation. Example. Now suppose, consider this particular as a graph. This is a graph, and let me label this graph as G. Suppose this is graph G. And I wish to identify its adjacency matrix. Let me label that as a A. दिखाई दे रहा है ना, प्रोजेक्टर के ऊपर दिखाई दे रहा है ठीक से, रेड कलर विजिबल है, या तो फिर ब्लैक चूज कर लूं, ठीक है. That question was for offline students. Okay, guys. Now I will pick one of the student from online. Let me pick Isha Dadania. Isha, are you there? Isha, are you there? Vibhusha bhag gayi dekh. Isha, can you unmute yourself?
Yes, sir.
Good. Chal bata beta. Now, if you wish to identify adjacency matrix of this graph, then first of all, provide me the order of this matrix. इस adjacency matrix का order क्या होगा? How many vertices we are having in this graph? 6 vertices, is it? So order of my adjacency matrix will be 6 cross 6. 6 cross 6. Are we good? 6 cross 6 matrix will be there, and let me label all of them: V1, V2, V3, V4, V5, and V6. Similar labeling will be provided over column V1, V2, V3, V4, V5 as well as V6. Is it? चल विभूषा, अब तू बता बेटा एंट्री क्या V1 के साथ कोई कनेक्शन है? Where is V1? V1 is here. Observe, this is V1. Do we have any cycle over V1? No. So this entry will be 0. Is it? Vibhusha, if possible, then stay unmuted. Vibhusha, if possible, then stay unmuted. Sorry, Isha, not Vibhusha. Isha.
Yes, sir.
हाँ, अनम्यूट ही रहे, बात कर हमसे. चल फर्स्ट रो की सारी एंट्री लिखवा. चल
हाँ सर.
V1 का कनेक्शन किस किस के साथ है देख.
V2 के साथ सर.
एक V2 के साथ है ये वाला, फिर V6 के साथ है, एंड V5 के साथ है. खत्म ना?
Yes.
तो तुझे V2 में 1 देना है, V6 में 1 देना है, as well as V5 में 1 देना है, and rest of all the entries will be 0. As simple as that. Is it? Now let me pick one of the person from the offline. Yes, you will give me the second row. Dharmik. Yes, Dharmik. V2 का V1 के साथ connection. Let me erase this. You just need to check the degree of that vertex. कितनी डिग्री है देख. V2 की 3 डिग्री है, तो 3 बार 1 की एंट्री आएगी यहाँ. ठीक है? V2 with V1 is there. V2 with V2 will be 0. V2 with V3 is 1. V4 के साथ 0, V5 के साथ 0, and V6 we are having one of the connection. Is it? So this is the way we can identify adjacency matrix. Surely it will be a 6 cross 6 matrix. In each and every case, it will be always a square matrix. Whether we are dealing with the 3 number of vertices in a graph, then that matrix will be 3 cross 3. If we are dealing with the 4 vertices, then a matrix will be 4 cross 4. If we are dealing with the 5 vertices, then that matrix will be 5 cross 5, like that. Is it? So let me show you the entire matrix. Just go through it. This is the adjacency matrix of this particular graph. Are we good?
Yes, sir.
समझाइए बताना. Good. I don't think so. कोई issue होगा जो भी online पढ़ रहे उसको भी. Is it now? Waldy, are we good with this, Waldy?
Yes, sir.
Waldy.
Yes.
Good. Yep, Sira. Yep, Sira. Are you comfortable? Are you getting all this? Yep, Sira. Yes.
Yes, sir.
Are we good with this? Are you getting my point?
Yeah, I'm getting your point, sir.
Good, 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 good. Mute yourself then. Some of the observations. I'm not going to read. Just go through this. Just go through this. Giving you 2 minutes. This is some of the observations from which we may list out from the adjacency matrix. Just go through it. Just go through it and let me know. समझ में आ रहा है कि नहीं आ रहा है? The entries along the principal diagonal of the adjacency matrix are always 0. If and only if graph has no self loop. The entries over the principal diagonal will have 1 if and only if that particular graph is having a kind of self loop over any of the vertex, is it? If each of the vertex are having self loop, then surely all the entries over the principal diagonal will be 1, is it? Why? Because observe this particular entry. What is this? This is a place which connects V3 with V3, is it now? Which connects V3 with V3. If a graph, suppose this is a V3 vertex, and if we are having a kind of self loop over there, then surely this entry we need to convert that particular as a 1. We need to enter 1 over there, is it? Yeah. In next coming example, we're gonna allow self loop even, is it? So it's not like that. In each and every case, graph will be simple. ऐसा नहीं होगा, ठीक है? Then after the definition of adjacency matrix has no provision for parallel edges. We are not going to allow parallel edges. Why we are not allowing parallel edges? If suppose what will be the problem if suppose I'm having a graph A B C D with the vertices A B C D. This is a kind of simple graph yet, and if I'm giving one more edge over there, then what will be the issue? क्या problem face करेंगे? Yeah. Hopefully you are getting this. In this case, yes, please.
सर बट अगर हम फिर भी इसकी एडजेसेंसी मैट्रिक्स बनाने की ट्राई करें तो सर ए और डी के बीच में अगर हम 1 की जगह 2 लिख देंगे तो फिर भी हम ऐसे डिनोट तो कर ही सकते हैं, मतलब समझ जाएंगे ना कि 2 है तो 2 पैरेलल एजेस होंगे, वैसे जितने पैरेलल एजेस होंगे वो नंबर लिख देंगे 0 1 की जगह.
Correct, Rishabh. Your one of the concern is totally okay, but what we are trying right now, we are trying to deal with the binaries entry only. As we are going to fit this particular matrix in your some of the code, and you guys are quite good that your computer understands only 2 figure, 0 and 1, is it now? So
yes,
when we will be dealing with such graphs, we will be dealing with the directed graph. और इसके लिए कुछ हम प्रोविजन करेंगे, पर अभी के लिए when we are dealing with adjacency matrix, we are not allowing self loop. We are not allowing any of the parallel edges, is it? क्योंकि अगर parallel edges है तो respective entry आपको 2 करनी पड़ेगी, is it? Because we are having 2 different edges which connects V2 to V3 or V1 to V3 like that, and that number 2 is not allowed right now in the adjacency matrix. So each and every entry in the adjacency matrix will be either 0 or 1. Are we good?
सर अगर बाइनरी में भी डालना ही है तो फिर 2 को बाइनरी में लिख के भी डाल सकते हैं.
कर सकते जैसे वो आगे धीरे करेंगे. वेट कर.
ओके सर.
Oh God, it's already 1:08. Let me stop over there. Wait guys, once again we will be meeting at around 2. We will start our next session at 2, sharp at 2, okay? So I'm giving you lunch break, all of you, all those who are in front of me. I'm having 7-8 students in front of me. So quickly go and take your lunch. We'll be meeting once again over here at over this particular place only, but those who aren't me and I take it. And once again, we'll start from here. यहाँ पे आना है, ठीक है, अटेंडेंस